Hey everyone, sorry I'm out again today, but this video here will walk you through the rest of page 2 and all of page 3 in your note packet, which deals with more of how to write these linear equations using point-slope form, converting them to slope-intercept. There's just more ways that we can pull the information to get the same things that we talked about in class yesterday. So I'm going to walk through the different examples here, take down the things that you need to take down. Each part of the notes here has 2 examples of each, so if you understand at least one, you'll be in good shape. So on page 2 here, if you're in the middle of the page, you're given a couple of tables, and we're going to use the tables here to write equations that end up being in slope-intercept form. So, like we talked about yesterday, if you're not explicitly given the slope and the intercept, we start off in point-slope form because we can at least do something from there. So if you look at the tables, these tables are ordered pairs. They're XY tables. We can just write them as ordered pairs. So like for the table A here, I can write it as -4, -2, -2, -1, and 0, 0. So I can take these ordered pairs and I can do stuff with them. I have more ordered pairs than what I need, but in order to write an equation, I need points and I also need a slope. So we're going to go ahead and take 2 of these points and go find a slope. It does not matter which 2 points you choose. You can pick whichever ones you want. Again, we talked a little bit about this yesterday. Pick stuff that might make the math easier. So what I'm going to do here is I'm going to use the points -2, -1, and 0, 0. If you have stuff with zeros, that can make the math a lot faster and a lot easier. But we got to go find the slope between these points first. So we're going to go ahead and quickly do that. So we'll do a little y2 minus y1, so 0 plus 1 over x2 minus x1, 0 plus 2. I end up with a slope of 1/2. Once I have my slope, I'm going to use that, one of the points, and I'm going to go ahead and start writing things in point-slope form. So we talked about that yesterday. That's like y minus y1 equals m times x minus x1. I'm going to use my slope of 1/2. I'm going to go ahead and use the point 0, 0 because, again, we got 2 zeros. It's going to be really easy to plug stuff in and move through the math pretty quickly. So plug in 0 for y1, 1/2 for m, 0 for x1. All I'm going to do here, so this is again in point slope form. If I want to turn it to slope intercept form, which we're going to do probably 9 times out of 10 with most of these problems, we got to get y by itself. So first thing I'm going to do is distribute. So I get 1/2 x, 1/2 times -0 just becomes 0, so I'm not even going to write it. And then I look at the left side here, y minus 0. Well, if I take away 0, that doesn't really do anything. So I have a slope-intercept equation of y equals 1/2 x. I can do the same thing with the next table. Again, I have 3 ordered pairs to choose from. -4, 6, 4, 4, and 12, 2. I'm going to go ahead and use the 2 positive points, 4, 4, 12, 2, because there's no negatives involved there, less chance of me making a mistake. Same process. I'm going to take 2 points, find the slope. So 2 minus 4 over 12 minus 2. That gives me -2 over 10, which will simplify to -1 over 5. Now I'm going to go ahead and use that to write an equation in point-slope form. So again, once I do this, now if I look at this, there's nothing with a 0, so we're not going to be able to make it super easy. I would probably just pick a point that has positive numbers to it, so I'm going to go ahead and pick 12, 2, just because I can. So the 2 is the y-coordinate, so that's going to go in for y1, -1/5 for m, and then the 12 goes in for the x1. Once again, so that's in my point slope form. I'm going to go ahead and distribute. So I'll get y minus 2 equals -1/5 x. -1/5 times -12 is positive 12 over 5. So we do get a fraction here. Again, not a big deal. We're writing equations here. We're not graphing it, so you'll probably see, again, more fractions as we work through this. Then to get y by itself, I add 2. Y equals -1 over 5x. Make that a little easier to see here. -1 over 5x. 12/5 plus 2 would be the same as adding 12 over 5 plus 10 over 5. That gets me a final answer of 22/5. to tack on there at the end. If you struggle with messing with fractions, my biggest tip would be to use your calculator and convert things to improper fractions. If you struggle with fraction math at this point, that would be my best solution for right now. If you can do them in your head, great. But again, you have calculators. Go ahead and use them. So that's your process there. If you have a table, you've got sets of ordered pairs, pull them out, go find the slope. Once you have your slope, take that, take a point, plug it into point slope, and work it through like we talked about yesterday in class. So that's another way you could see this set up, how you can get your information and pull everything out to make an equation. The next way is if it's written in function form. Now we messed a little bit with this here at the end of the last chapter. We're going to see it pop up a little bit more in this chapter as well. So key statement here, if you look at the bottom of page 2 there, if it's in function form, it basically is saying f of x equals y. So quick little example here. If I gave you f of negative 2 equals 20, means the x value is negative 2, because that's what's in the parentheses there, and it's equal to 20, that 20 is that y value. The reason why knowing that's important is if I give you things written in function form, they're just written as ordered pairs. They just look really fancy. So if I look at the first example here, I have f of 0 equals 5 and f of 4 equals 17. Well, the number in the parentheses is the x, the number that it's equal to is the y. I can just rewrite these as ordered pairs. F of 0 equals 5 is the same as 0, 5. F of 4 equals 17 is the same thing as 4, 17. Guess what? This looks exactly like what we just did up in the problems with the tables. I have 2 points. If I have 2 points, I can use them to go find the slope. So once again, I'm going to use my slope formula, 17 minus 5 over 4 minus 0. So I'll get 12 over 4, which is equal to 3. I have my slope. I have a couple points to choose from. I'm going to go ahead and use the point 0, 5 because there's a 0 involved. And I'm going to go ahead and write out my equation. So once again, I'm going to start in point slope. In for y1 is going to be the 5. My m is 3. My x1 is 0. I have it in point slope. I'm going to convert it to slope intercept. The same 2 steps. Distribute the 3. So y minus 5 equals 3x. 3 times negative 0 is 0, so I don't write it. Then, to get the slope intercept, I'm going to get y by itself, add the 5. I get y equals 3x plus 5. Second example is the exact same idea. If I have 2 things written in function form, I've got 2 ordered pairs. So f of negative 2 equals 15 is the same thing as the ordered pair, negative 2, 15. F of 1 equals 9 is the same thing as 1, 9. You got 2 ordered pairs, go find the slope. So 9 minus 15 over 1 plus 2. Again, same as 1 minus negative 2. So that ends up with negative 6 over 3, which simplifies down to negative 2. So now from here, I'm going to go ahead and write out my equation. So use a different color here. Hopefully you see this a little bit better. So again, I'm going to use the 0.19 just because, again, they're both positive numbers. Makes the math a little easier. I don't have to change as many signs. But again, it doesn't matter which point you choose. The math will work out. So in for y1, I'm going to put in the 9. A negative 2 for m. And the 1 goes in for x1. Same 2 steps. Distribute. So I'll get negative 2x plus 2 on the right. Add the 9. I end with a final equation of y equals negative 2x plus 11. So that's another way, again, we can write equations. You can have things written in function form. If something's written in function form, again, all you have to do, turn that function form into 2 ordered pairs. Once you have 2 ordered pairs, go find the slope, plug it into the point slope form, work your way through the steps. So again, another way you can get information, pull it all out, write an equation from it. The very last way that you can do it, so if you go ahead and flip the page to page 3 in your note packet, is if you have it from a graph. So if we take a look at the 2 graphs here at the top of page 3, you have all the information you need to go ahead and write an equation. It's now just a matter of how do you get the stuff you need. So when you have a graph, you can easily find the slope by doing rise over run. You can use a slope form if you want because you have two nice easy points that you see in each graph, but what's going to be faster is if you can count blocks. So in the first graph here, I'm going to go ahead and find the slope. So I count up 1, 2, 3, 4 spaces, and to the right 1. So my slope would be 4 over 1, which is 4. Make sure you're doing rise over run, which means you're counting up or down first, then going left or right. Make sure you do that in the correct order. Otherwise, your slope will be backwards, and you're going to get the wrong equation. So my slope here in this case is a positive 4. I have a couple points to choose from. I'm going to go ahead again and pick the point that has both positive numbers, 4, 1. So, same process. You have a slope, you have a point, plug it in. So in for y1 will be the 1 off that ordered pair, in for m will be 4, and in for x1 will be the 4 off the ordered pair. Same steps. Distribute. So I get y minus 1 equals 4x minus 16. Then add 1. You get y equals 4x minus 15. That puts it in slope-intercept form. The second example is the exact same process. You've got 2 points on the graph you can easily work from. Let's do rise over run. So to get from one point to the next by rise, I'd have to go down 2, and then over 1, 2, 3. It looks like we're going over 4 spaces. So my slope would be negative 2 over 4. Again, always reduce. In this case, my slope would be negative 1/2. I'm going to use the point 1, 0. Once again, positive numbers, and we have a 0 involved. I'm going to prefer that one every single time. And we do the same thing over and over again. It's a very tedious process, as you've noticed, but again, if you can do it once, you can do it out of a whole bunch of different setups. So we go plug in what we know. The y1 from the point would be 0. The m is negative 1/2. The x1 is 1 from the ordered pair. We distribute. Keep in mind, y minus 0 just becomes y, because subtracting by 0 doesn't do us any good. When I distribute, I get negative 1/2 x plus 1/2. And that's my equation in slope-intercept form. So now you've basically learned all the different ways you can pull out the information if I just give you numbers or graphs or tables or function form or whatever. There's a bunch of different ways you will see the information available to you. It's just a matter of pulling out everything correctly, putting it in the right spots, and making sure you do some basic math correctly to get y by itself, all those sorts of things. So those are your different ways that you can go ahead and find point slope form and convert it to slope intercept. If you look at the problem underneath here, all it says, number 3, is just in words, describe the steps you would take to write an equation, slope intercept form. So if I had to put this in words, again, you just heard me talk through it here for the last 10 minutes or so in this video, and we talked about it yesterday in class. But if we're just going to put this in words here, if I give you information where I only give you 2 points, first step would be take the 2 points and find slope. That would be the first step given the information that's in this problem. The second step, we'd plug in the slope and a point into point slope form. If the goal is then to take it to slope intercept form, we would solve and rewrite the equation so that y is by itself. So if you had to describe it in words, that's basically what it is. It's a 3-step process. You have 2 points, take them and find the slope. Second step is to plug in the slope and the point into point slope form. Then if we're going to take it to slope intercept, we have to move things around, rewrite the equation so that y is by itself. So all that question there is just asking you to put it in words. For some of you, that might be helpful just to kind of see those steps kind of summarized like that. Okay, but again, it's the same process. It's just asking to put it in words. The last little bit of the notes there, we got a couple of classic describe and correct. So I'm purposely making a mistake in these problems. So here I'm telling you, I'm giving you the point 1, -5 has a slope of -2. So somewhere in this problem here, I have a mistake on purpose. If you take a quick second and look at it here, keep in mind, you got your point is x1, y1, your slope is m. First thing we should check to see is, let's make sure the stuff's plugged in correctly. So, keeping in mind our format, y minus y1 equals m times x minus x1. Let's see if the stuff's plugged in right. So, the y1, we'd have to plug in a -5. Well, I already found my mistake. If my goal is y minus y1, it would be y minus -5. Y minus -5 should be written as y plus 5. So I've already found my mistake in the very beginning of this problem. So the error is simply this. -5 was plugged in incorrectly. The way that we would fix it, if it's supposed to be y minus -5, we would say y plus 5 equals -2 times x minus 1. Having one sign off in this problem is going to make a big difference. So if I continue with my problem here and try to get it to slope-intercept form, again, we distribute. So it'd be -2x plus 2. So the right side, that's not an issue right now. But if I subtract 5 to get y by itself, there's a difference in my answer. All of a sudden, my equation becomes -2x minus 3 rather than -2x plus 7. Which, again, in the grand scheme of things, maybe that doesn't seem like a big difference, but they are two different answers, and they would graph as two different lines. So, changing a sign is going to make a difference here. You have to make sure you plug in things right. So that would be the issue here in number 4, -5 plugged in incorrectly. Looking at 5, same idea. I give you 2 points. So x1, y1, x2, y2. So we know if I give you 2 points, we first have to find the slope. So let's check and see if everything was plugged in correctly. Should be 2 minus 0, okay. -3 minus 3, that looks fine. And we get 2 over -6, and we simplified it. Here's the issue. 2 over -6 doesn't magically become positive 1/3. The only way it would be positive is if both of those numbers were negative. Well, they're not. The issue is your slope. So the error was that the slope was simplified incorrectly. Because what should have happened, it shouldn't be positive 1/3, it should be negative 1/3 based on the math that we have. So that's going to make a huge difference in our equation as well. So we're going to fix it. Instead of having positive 1/3, we're going to make sure it's a negative 1/3. So I'm going to write out here in slope, the point slope form, y minus 0 equals negative 1/3 times x minus 3. Because the point was plugged in correctly, that wasn't the issue. The slope, though, should be negative, not positive. The difference it's going to make is this. So we know it's going to be y on the left side, because again, minus 0 does nothing. Negative 1/3 x, negative 1/3 times negative 3 is a positive 1. It's a completely different equation. Same numbers, same digits, but the signs are both different, which means your line's going to go the opposite way. So again, losing a negative sign, no different than the last problem. You miss a sign, you screw something up with that, it's going to make a big difference in your problem. So that wraps up the notes for writing linear equations. So again, use that here. We're going to see use that to finish off the homework that goes in your homework packet. I think it's the rest of page 2 and all of page 3. Similar problems to what I just went through here. We'll see more of this as we keep going throughout the chapter. It's going to be the same process over and over again. So if you have any questions about anything, shoot me a message or we'll talk about it tomorrow in class. Thanks for watching.